Hello students, welcome to the new class. In this class, we will study about the transportation problem, which is our next step to go to solve the different type of problems as we have discussed in the initial classes, that we have the application of operation research or the quantitative technique in the different areas. So we have now the transportation problem to solve. The objective of this lecture is basically we will study about the transportation problem. Now, transportation problem also can be converted into the LPP. So we will study about the LP formulation of the transportation problem. Then we will study about the initial basic feasible solution. What is the meaning of the initial basic feasible solution is that when we are going to solve any problem, we are getting the initial basic solution. Like if you remember that in the graphical method, what we have done, graphical method when we have solved that, the graphical method gives us the corner point at the end when we are finding the feasible reason. So each and every corner point is my feasible solution. When we are talking about the feasible solution, that means these can be my solution, but these I cannot say that these can be the optimum solution. So whenever we are talking about the initial basic feasible solution, so these are my solution but are not optimum. It may be optimum, but that has to be checked. So in the graphical method, when we have solved an LPP by graphical method, so that was giving me the different type of the solutions, the corner points. So out of that we have find out the optimum solution. So here we have the three methods to find out the initial basic feasible solution of a transportation problem. One is northwest corner method, which is also known as a short form NWCM method. Second is the least cost method, that is a LCM method. And third one is the Vogel's approximation method, that is WAM method. This WAM method or the Vogel's approximation method is also known as a penalty cost method. Now, this is basically a structure of a transportation problem, how the transportation problem looks like and what is the transportation problem basically. The transportation is basically when we have to transport the material from one source to the different destinations. So if you see that these are the equations, or these are the table where what we are doing, we have the different sources and the different destinations. So what I have to do, I have to transport the material from the different sources to the different destinations. So we will be having in a transportation problem the sources with the availabilities or the supply, the maximum values, and the destinations with the demands or the requirements. So here, and the unit cost of the transportation from the various source of destinations. So this C1, C2, C11, C12, C1M, these all are my cost. Now, if I will explain this table, so you understand that this S1 is my first source, and I have to transport the A1 units, which are the maximum availability or the maximum capacity of this source, to the different destinations. It's not that I will transport all the A1 to the D1 or all A1 to the D2. It might be that some of the portion of D1 at the D1, some of the portion at D2, or might be possible anyone, the full-fledged allocation. So this C11 is basically the cost of transporting one unit from S1 to D1. Similarly, if I am talking about this C32, C32 is the cost of transporting one unit from S2 to D2, S3 to D3. So these are what? These are my the sources and the destinations. And this A1, A2, A3, AN, these are the maximum supply which can be done from this S1, S2, S3 and Sn. Similarly, this B1, B2, B3 and Bm are my demand the of the different destinations. So D1 demand is B1, D2 destination demand is B3, and D3 demand is B3, and so on. Now there is a concept says the balanced and the unbalanced transportation problem. If the total supply is equal to the total demand, then this is known as a balanced transportation problem. If the total supply is not equal to a total demand, then this is known as an unbalanced transportation problem. Now the objective of the transportation problem is we have to determine the schedule of transportation to minimize total transportation cost. That means our objective is that the total transportation cost should be minimum. Now we have this one kind of a problem. Here you can understand the concept of the last PPT. That is, here in this we have the three sources, that is the A, B, C, and the four destination, that is P, Q, R, S. We have the different routes, that is the 12 routes are available because this is A 3 into 4, that is A to P, A to Q, A to R, A to S, and similarly B, similarly C. Now the aggregate demand of all the destination is 1000 units, and the total supply of the all the sources is 1000 units. So it is basically a balance problem. If it is not balanced, then it is means if the supply and the demand are not same, then it is known as an unbalanced transportation problem. Here if I will explain this 11 is basically the cost of transporting one unit from B source to the Q destinations. So for example, if I transport 150 units at this place, so it will cost me 11 into 150. That is, the transportation cost from B to Q will be 11 into 150. Similarly, if I'll transport the 300 unit at this place, so it will cost me 300 into 14. So from B to S, the cost will be 14 into 300. So this is basically a transportation model or transportation problem which can be seen. Now we will solve this transportation problem with the different methods to find out the initial basic feasible solutions. Now, as we discussed earlier, that this transportation problem can be converted into a LPP form. This transportation problem is a particular case of a LPP. So, how this transportation problem can be converted into an LPP? In an LPP, what we want the objective function and the constraints are basically the restrictions. Now, if you see here that the restrictions are basically, or the objective is basically to minimize the cost. Now the cost minimization is that we have to first identify the variables, identify the decision variables. So what we are assuming that the x11 is the number of units which are to be transported from A to P. Similarly, x12 will be the number of units which are to be transported from A to Q. X13 will be the number of units which are to be transported from A to R. X14 will be the number of units to be transported from A to S. Similarly, x21, x22, x23, x24, x31, x32, x33, x34. So total number of variables are 12, and the constraints would be 3 constraints for the supply and 4 constraints for the demand. So total constraint would be 7. Now how to make the LPP from this transportation problem? My objective is to minimize the cost. What I'm doing, I'm transporting x11 unit from A to P. So my cost will be 12 into x11. I'm transporting x12 units from A to Q. So my cost of transporting from A to Q will be 10x12. So this objective function, this minimum z is my objective function, 12x11 plus 10x12 plus 12x13 plus 13x14 till 7s34. So this will be my objective function. Now I have to make the constraints. So constraints are basically whatever the number of units you are transporting from A, that cannot be your greater than 500 or less than 500. It should be equal to 500 because we have to complete this supply. So x11 plus x12 plus x13 plus x14 less equal to 500. Similarly, x1, x21, x22, x23, x24 equal to 300, and x31, x32, x33, x34 equal to 200. Now for the destinations, the total demand is 180 for the P. So this is x11, x21 plus x31 equal to 180. Similarly for the Q, for the R, for the S. Now, since these all are the number of units x11, x12, x13, so I cannot transport any negative units. So my all xij should be greater than equal to 0. That means all the decision variables should be greater than equal to 0. Now remember one thing over here, that whatever the order of the matrix, the order of the matrix is 3 by 4. So the 3 by 4, that means 3 plus 4, 7 will be the constants, and 3 into 4 will be the number of variables. So we can ask, or anybody can ask, that if you have a problem of 3 by 4, that what will be the number of constants and how many variables. So if we are saying that the m, the number of rows, and n, the number of columns, so m plus n will be the constants, and m into n will be the number of variables. Now the methods which we will use to solve the transportation problem. The step one says that if my transportation problem is unbalanced. Unbalanced means if my total supply and the total demand are not same. That means I have to make them equal. I have to make the problem as a balance. And how to make the problem as balance? We use the dummy row or the dummy column to make the problem as balanced. Second step says, or the next thing is, that if in some of the cases the sum of the roots are probated, that means we cannot go with that particular area or that particular root, so we have to put an m, which is which has no meaning. That means m is just to say, just to identify that we cannot go there, we have to no value there, we cannot put zero also there. So we will put just m over there if any cell or if some root is probated, and convert into an equivalent minimum problem if it is a maximum problem. If my objective or my problem is a maximum problem, I have to convert this into a minimum problem. Second step says that we have to find out the initial solution, which I have discussed, the initial basic feasible solutions we have to find out. And the methods are northwest corner method, second is least cost method, and third one is the Vogel's approximation method. This Vogel's approximation method is known as the best method among the three methods, because this method gives me the minimum least cost out of these three methods. Now the first method is northwest corner method. In the northwest corner method, what we have to do, we have to deal with the directions. As we know that the corner method, that means the directions are east, north, west, south. So the northwest corner method, the northwest corner will be the left uppermost corner of any table. So we have to start with this point. So at this point we have to see that how much we can allocate. That particular terminology is known as a maximum possible allocation. So maximum possible allocation doesn't mean that the maximum allocation. It is maximum possible. What is the meaning of this maximum possible is that if from this A, the A can supply maximum unit of 500, but the demand of P is only 180 units. So we will not go beyond the 180 units from A, because the only demand of P is 180. So we will give the maximum possible amount over here, the 180. That means the maximum possible units will be 180. So this is the concept of the maximum possible units. Now we have to start with the left uppermost corner of our table, that is the northwest corner. From A to P, how much we can transport. As we have seen that the demand of the P is 180 and the supply from A is 500. So we will give the maximum possible, that is a 180 units to A to P. Now if we are giving the 180 units from A to P, then the remaining units of a supply of A will be 320 only, and the demand will be A will be completed. So we cannot move now here, because we don't have the another units to supply or to the demand of P. So the demand of the P has been fulfilled. Now this column is vanished. Now we have to move to the another column, that means the left uppermost of the table. So this is my left uppermost corner of the remaining table. At this point the demand of the Q is 150 and the supply of the A remains as a 320 now. So we will give 150 as a maximum possible units to A to Q. So after this the demand of the Q is fulfilled, but the supply of the A will remain 170 balanced. So now this R is my the left uppermost corner of the remaining table. At this point the demand of the R is 350, but A can supply only 170 units. So we will give the maximum possible allocation, the maximum possible units of 170 to A to R. Now At this time, the supply of A is over, but the demand of R is remaining 180. Now we will go for the next table, that means this portion. And in this portion, the maximum possible unit is that supply of B is 300 unit, but the demand of R is rest as a 180 units. So we will give them 180 units as a maximum possible units. So after this 180 unit giving after to the R, the demand of this R is over, but the supply of the B will remain as 120 balanced. Now this 120 can be given at the B2S, so because this is the left uppermost corner of this table. So we will give the 120 units at this place. After this, the supply of B is over, but the demand of the S would remain 200. Now if we see at the last point, the demand of the CS is 300, 200, and the supply is also from the 200 from the C. So we will give the maximum possible unit, that is a 200 at this point. So this can be completed. Now this is my allocation, this is my route to transport. Now I have to find out the total transportation cost. So as per the LPP, this is 12 into 180 plus 10 into 150 plus 12 into 170 plus 8 into 180 plus 14 into 120 plus 7 into 200, and this comes out to be 10,220 rupees. That is, this is my total transportation cost if I'll go with the NWCM method. So this will be my transportation cost. Now the next method is least cost method to find out the initial basic feasible solution. In this least cost, as we are saying the least cost, that means we have to identify the least cost of this cost matrix. That means out of all the costs, first we have to find out the least cost, and we will give the maximum possible allocation to that least cost first. After that, again we will find out the least cost, and then we will go accordingly. So in this table, the least cost is 6. So we will give the maximum possible allocation to this 6. That means if we see that this point is the intersection point of C and P, the demand for the P is 180 units and the supply of the C is 200 units. So the maximum possible allocation at this point is 180. So when we are giving this 180, that means the demand of this P is over. Why I am highlighting this as a red color? Because these red color means that I cannot give the allocation to any other unit or any other place apart from this 6. So these are the red highlighted cells. That means this is a block area. Now when this is a block area, apart from this block area, I have to find out the next minimum value out of this area. So out of this, I have the minimum balance as a minimum unit as a cell as a 7. Now if you see that after giving this 180 unit, the demand of the P is over, but the remaining supply of the C would be 20 units. Now this is the minimum cost, the least cost of the next least cost of the matrix 7. Now this 7 is the intersection point of C and S. The demand of S is 320 and the supply of the C is only 20 units. So I will give the maximum possible allocation as a 20 units to this place. Now after giving this 20, the maximum possible units, that the supply of the C is over. That means I have highlighted this as a red cells. So I cannot give the any other units allocation. So and after giving this 20 units, the remaining demand of this S would be 300. Now after this, so this column is go over, this row is over. I have only these 6 values. Out of these 6 values, again I have to find out the minimum value, least cost, that is a 8. At this place, I have to see that the demand of the R is 350 units and the supply of the B is 300 units. So maximum possible value or the maximum possible allocation at this point is 300 units. And after giving this 300 units to this point, the supply of B is over. So these two cells are highlighted with the red color and the demand of the R is still remain 50. Now after giving this, we have only left with these 3 cells. So we have the 10, 12 and the 13. So 10 is the least cost. So I will give the first priority to this one. So this 10, that means that A to Q. So the demand of the Q is 150 and the supply from A is 500. So I will give the maximum possible allocation, that is a 150 units to Q. After giving 150 units to Q, this column is over and the remaining supply of the A will be 350 units. Now this is the second point, that is a 12. 12 is my the least cost of this out of 12 and 13. So the demand for the R is 50 units and the supply is 350 units. So I will give the 50 units to at this place. After that, my balance supply of the A is 300 units. Now this is the last point. I have to see that the demand of the S is 300 and the supply of the A is also 300. So I will give the maximum possible value of this point, that is a 300. So these yellow cells are my allocated cells. So if we go with the allocation sequence, I can say that the allocate 180 units to the route A to P first initial. Select least cost cell CP, that is allocate the 180 units. Determine the column P and is the supply at the C to 220 units and so on. So my total cost at this time is 10 into 150, 12 into 50, 13 into 300, 8 into 300, 6 into 180 and 7 into 20. So this comes out to be 9620. If you remember the previous cost by the NWCM method, that was 1020, 222, 20. So this cost is minimum or the least from that particular method. Now the last but not the least method of this transportation problem to find out the initial basic feasible solution is WAM, that is a Vogel's approximation method or the penalty method. Now this method is mostly applicable because this also give me the least cost out of all the methods. So the steps of this WAM method are that first, we have to involve obtaining the cost differences. That means we have to find out the penalties. Penalties are basically the difference of the two minimum cost of a particular row or a particular column. If that means, if for example, if we have this first row, that means the costs are 12, 10, 12, 13. So the minimum costs are 12 and 10. The difference of these two costs is 2. If I'll go with this 6, that means the S column, that means the costs are 13, 14 and 7. So the minimum costs are 7 and 13. So the difference is 6. So the steps is that we have to find out the penalties for each row and each column. That is the difference between the two least cost. After that, we have to select the largest of the cost differences. That means out of the penalties, we have to find out the maximum value of the penalty. Then we will enter in that particular row or that particular column and we will give the maximum possible allocation to the least cost of that particular row or that particular column. And accordingly, we will eliminate or we will delete the row or the column which is over by the supply or the demand, and then we will go for the further process. That means at each and every point we will find out the penalties till we have the two rows and the two columns, because we have to compare. Now let's start with this problem. The first row has the penalty as a 2. Second penalty, the costs are 7, 11, 8 and 14. So the minimum costs are 8 and 7. So the penalty is 1. In the third third source, we have 6, 16, 11, 7. So the minimum costs are 6 and 7. So the penalty is 1. Now from the P column, that is in the P destination, the costs are 6, 7 and 12. So the minimum costs are 6 and 7. The penalty is 1. In the Q column, the costs are 10, 11, 16. So the 10 and 11 difference is 1. Here in this R column, that is a 12, 8 and 11. So 8 and 11, that is the difference is 3. Now here 13, 14, 7. So 7 and 13 difference is 6. Out of these penalties, we have to find out the maximum value of the penalty. So 1, 1, 3, 6, 2, 1, 1. Out of these 7 penalties, the maximum value is 6. So now we have to enter in this particular column, and in this particular column we will identify the least cost of this column. So the least cost of this column is 7 and we have to give the maximum possible allocation to these least costs. The maximum possible allocation means that the supply of the C is 200 units and the demand of the S is 320 units. So we will give only 200 units to this place. After giving the 200 units at 7, the supply of the C is over. That's why these cells are red highlighted, and 7 is green highlighted because this is a allocated cell. After giving this 7, then we have to find out again the penalties. Since this row is eliminated, therefore we will not find out the penalty for this one. So for the A, that is the penalty is 2. For B, the penalty is 1. For P, now the penalty is 5 because this 6 is over. Now the two costs are remaining, that is the 12 and the 7. So the penalty is 5. 10, 11 penalty is 1. 12, 8 penalty is 4. 13, 14 penalty is 1. Now out of these 7 penalties, we have to again find out the maximum value. So this 5 is my maximum value of the penalty. So I have to go in this particular column and I have to select the least cost. Now the least cost of this is not 6 because 6 is already eliminated. So out of this 12 and 7, the 7 is the least cost. Now I have to give the maximum possible allocation to this 7. So for this P, the demand is 180 units, and for B, the supply is 300 units. So I will give the maximum possible value, that is a 180. So my cost is my demand for the P is over, but the supply of the B will remain 120 units. Now after this, again I have to find out the penalties for the. Now this column is over. Now this, for A it is 10, 12 and 13, so the penalty is 2. For B it is 8, 11, 8 and 14, so penalty is 11 and 8, that is 3. For P we will not find out the penalty now because this column is eliminated. For the Q, 10 and 11, 1. For R, 12 and 8 is 4. For 13, S, 13 and 14, that is 1. Again, out of these penalties, we will find out the maximum value of the penalty, that is 4. We will enter in this particular column, and in this particular column we will find out the minimum cost. The least cost is now 8. So the demand for the R is 350 and the supply for the B is 120. So we will give the maximum possible allocation at this place, that is a 120 units. Now after giving 120 units to this one, my B is over. Now if you see that the B cell is over, C source is over, only remaining with the A. Now I can find out the penalty for the A, but I cannot find out the penalty for Q and R because I need the two costs. So now at this stage I will not calculate the P4, right? So what I have to do now, I have to give the corresponding allocation to the remaining cells. So if you see this Q, that is a 10, I have 150 units over here and the demand is 500 units. So I will give the 150 units to this one. For R, this 230 units are remaining, so 230 units will be given. For S, 120 units are remaining, so 120 units will be given. Now if you sum this 150, 230 and 120, this comes out to be 500. So green cells here are my allocations, and if I will find out the cost, it comes out to be 10 into 150 plus 12 into 230 plus 13 into 120 plus 7 into 180 plus 8 into 120 plus 7 into 200, which comes out to be 9440, which is the least cost among all the three methods. So that's why this method, that is the least cost method, the WEM method, is known as the best method to find out the initial basic feasible solution. The recap of this video lecture is where we have studied the transportation problem. We have studied about the layout of the transportation problem. We have studied that how this transportation problem can be converted into an LPP. And we have also studied the initial basic feasible solution, that is the different type of solutions of a transportation problem to find out the initial solutions. And out of that, the WEM method comes out to be as a best method. Now the questions comes in the mind that what is the transportation problem and what are the meaning of the initial basic feasible solution. So transportation problem in which we have to transport the material from one point to the another, keeping in the mind that the total transportation cost should be minimum, because my objective is that the total transportation cost should be minimum. If it is not, then whatever the cost I am having in transportation, maybe it might be more than the cost of the production, so I will go for loss. So my concept is that the total transportation cost should be minimum. And what is the meaning of the initial basic feasible solution? That means which is giving me an idea that my cost can be of this one. It can be less than, but it cannot be more than this one. So initial basic feasible solution is basically to find out or to get an idea that this route can be followed to get the optimum solution. These are the books which can be referred as a references. You can go for any of the book to find out the different type of methods to solve a transportation problem and to get the introduction about the transportation problem. You can also find out the application of the transportation problem in the various fields. Thank you.